All right, guys, we'll make a start, hey? So has everyone managed to find that? It's pretty easy to find, yeah? I'll talk more about that, and we'll actually have a bit of a step through of how we're going to use that in the analysis of the bridge. So I guess last lecture we were up to around about the third step in this design process, and that was generating our solutions. Now, you should all have about 3 solutions that you're reasonably happy with for your bridge, okay? And now what we need to do is work out which one of those solutions is going to be the best, because you can't rock up on the day with 3 and just take the results from the best one. You get 1 bridge each, so we need to refine your design, improve your design, and work out which one is going to work. And so that's where step 4 of the design process comes in. So we need to analyse and select the best solution out of the options that we came up with in the preceding step. Now, the way that analysis might work, and obviously what you'll be learning over the next roughly 3 years, is how to actually do this analysis. Okay? So depending on which stream of engineering you go into, you'll have a whole suite of different analysis tools that you'll be using. You guys don't have those currently, obviously. So that's why you're not designing a real bridge or, a real machine component that's going to go out into service. You guys are designing model bridges and centrifugal pumps that we want to work once, and then we're quite happy for them to break after that. You might not be, but that's up to you. So now you won't be doing real engineering analysis on them. We'll be doing a shallow form of analysis, as much analysis as really gives you context for what this section is. But then you'll be learning over the next sort of 3, maybe 4 years exactly what type of analysis you will do for each particular discipline. But the analysis involved might be across a variety of areas. So the first one might be your detailed engineering analysis. Okay, and that's hand calculations. You might be using Australian or international standards. They have analysis procedures that you need to implement. It might be using computer models like finite elements or simulation techniques that chemical engineers use for processes and electrical engineers use to confirm their circuits doing what it's supposed to, and so forth. And it might be anything in between. Okay, so there are a lot of different areas of engineering analysis that you'll be learning to use. You might also at this stage do experimentation, and now that's not necessarily testing the final product. The final product testing comes in sort of section 5 or step 5. But the experimentation I'm talking about is if you've decided you want to use a particular type of balsa wood and you want to use a cross section for that balsa wood of whatever, half a centimetre by half a centimetre. How strong is that? Is that sufficiently strong, or is it too strong, or is it not strong enough? Because if it's too strong, you've got too much material and you can save a lot of weight. If it's not strong enough, you're not going to satisfy the criteria, and so forth. So at this stage, you don't necessarily do the large-scale testing, but you can do component testing. You can experiment on things. If you were talking about something in the mechanical world, and you're making something out of some sort of a machine component, then maybe you're using materials that you need to get more information on. So you do tensile testing on steel or carbon fibre or any of that kind of stuff, and then use that information to feed back into the detailed engineering analysis that you'll be applying. All right, so you can do experimentation at this stage, not necessarily on the whole system, but certainly on parts of the system and components thereof. All right. We're also going to be looking at things like function, weight, cost, safety, and so forth at this stage. If it's an engineering design that's going into something that people use, obviously safety is going to be a huge concern. Every engineering design, cost is a big thing. And it's obviously got to serve its purpose, so we need to make sure that that's being satisfied. And then once we understand all of these things, you might be able to put together one of the decision matrices that we were talking about last lecture. Some of these analysis techniques will rule things out immediately, right? So you might do some sort of a bridge design and you'll do the first stage of analysis and realise it's complete garbage. And you can, remove that. That doesn't need to go into a decision matrix if you've got really good reasoning to get rid of it. But if you refine and get to a couple of final designs that look like they're going to adhere to what you want, then you apply that decision matrix and you make your final decision based on the weights that you apply and all of that kind of thing. Okay? And so this is really where that decision matrix that we talked about last lecture comes into it. I wanted to go through it last lecture so that you start to think about it, but we can apply it at this stage probably more effectively than the last stage there. All right, so detailed engineering analysis. For this bridge project, obviously if you were doing an actual bridge and you're a civil engineer, you're probably going to be applying a hell of a lot of standards and codes of conduct and also things like finite element analysis and do a huge simulation of the whole bridge and parts of the bridge and understand where the stress is and optimise members based on that. You haven't learned any of those things yet. So what we're going to do is use this Autodesk force effect that I just got you all to download from the App Store. It's also a website, so if you don't like using it on an iPhone or an iPad, then you can use it on the web. It's a very simplistic program, but it will give you, it's pretty powerful in what it gives you. So what you guys do in statics and dynamics next semester will be to take a member structure like the types of bridges that you're talking about and work out how to calculate the forces on each member by hand. This program does that, all right? So you'll use this and then next semester you'll actually understand how it's calculating all of those forces. But I'm just going to give you a brief introduction to it because you'll need to apply this to every one of your bridge designs and try to learn some things from them. So this is the front end. If you hit the website that's linked in that PowerPoint there, this is what it looks like. The app might look slightly different, but it's fundamentally all the same. You can start with various types of projects. You can actually take a picture of a bridge and have that as your backdrop and then draw the structure over it and work out what the forces on that bridge are and things like that. It's really cool like that. There are lots and lots and lots of YouTube tutorial videos, so watch a couple of those and you'll be up to speed. It's basically as complicated as Microsoft Paint, effectively. So it's not a difficult program to use, but there are some sophisticated features in it. But what we're going to do is create a new design here. You can do kinematics too, which is moving stuff. So you'll do that in statics and dynamics next semester. You'll both do the static side and the moving side of, components moving around. You can do both of those in this software, which is really cool. It's simplistic but powerful, and sometimes the simple tools are the best. All right, so what we can do is create bridge members like this. So I'll just create a really simple bridge, and you'll see I've got a measurement there of 1.05 metres, and what we can do in settings is change between imperial and metric and the units in metres and newtons or millimetres and kilonewtons or whatever you want to use. This is fine, metres and newtons for me. And now if I want to change that measurement, I can just click on that and then click on the dimension and enter what I want. So let's say I want 0.5 of a metre. All right, that member's 0.5 of a metre now. Now I'll go ahead and draw some other bits and pieces, and then we'll go and put dimensions on them in a second. And there. It's going to be really messy, but we're going to put some dimensions on it, and it's going to fix it all up in a second. All right, so I have a bridge. It's a shitty bridge, but you'll get the idea. All right, let's make each one of these members 0.5 of a metre. Now, it doesn't matter if this rotates around a bit because we can fix that in a second. All right, so now they should all be 60-degree triangles. If I hold that, I can move it around and it should snap to the horizontal. There we go. All right, I've got a bridge. My bridge members are 0.5 of a metre, and that was very, very quick. Now, obviously, this is a very simplistic, crappy bridge, but you guys can, whatever the structure that you have, you can draw up in this and get the dimensions right and all of that kind of stuff. Now, obviously, if you're doing this type of truss bridge or whatever it is, you'll have one of these on either side, right? So you're only really modelling half your bridge, and what we need to understand is that if we're applying a force to half the bridge, the force needs to be half the force we're actually applying. Yeah, because you've got sort of half the structure, so half the force will give you the right, constituent forces and so forth. The way that this is drawn currently, each one of these is a pin. What that means is that it will quite freely move. There is no resistance throughout that joint. If I want to bond it, and if you're planning your bridge to have glue or whatever in the corners, All I do in this case is I right click that, and this is a standard joint, so a pin joint, and over here this is a bonded joint. So if I wanted to have welded joints all the way around here, all I do is that. Now on the app it's slightly different. I think you just hold your finger down on it and then that'll pop up, but it's basically the same thing because you don't have a right click on an iPad or whatever, obviously. Alright, so now all of my points are bonded. This is as if I glued it together. Before it was if I pinned it together. So, depending on how your bridge design's proceeding, you can have pins or bonds or whatever you want. Now what we also need to do is fix it to where the table is going to be at each side. So this little logo here, and if I click that, I've got a few options. This is fixed. So this is a fixed pin, which is basically like putting a pin through it. It can't move anywhere like that, but it can spin on it. Alright? This one is rollers. So basically it can slide left and right, but it can't move up and down. Which of those two do you think our bridge will be sitting on? The rollers, yeah, because we're not actually fixing to the table. If I put fixed pins at each of these, then I probably don't even need this top structure because this bottom horizontal member will be fixed. It'll be like kind of like a trampoline mat, yeah, and it'll just sag a little bit, but the tension between the 2 points will hold it. Now, for our circumstance, if we just have one member, we push it down, it's just going to fall straight down because nothing's holding it at either end, okay? Now, for this software, unfortunately, we can't put rollers at each end because that makes it statically indeterminate and the maths doesn't work, okay? So what we need to do is we'll put one fixed end and we'll put one roller end, and that'll be basically as good. So obviously the fixed end won't move, but the roller end, if I just had that single horizontal member, it would move in and the whole thing would sag down and collapse. Okay, so that's going to be as close as what we need for our actual application. And then this arrow here is my force. How much force, if you are carrying the 30 kilos, how much force is that in newtons? Does anyone know? So, roughly. So 9.81 is gravity. Engineers often use 10 because it's just easier in your head. So if you've got 30 kilos and gravity's 10, how much force? 300 newtons? Yep, so that's what we're going to do. We're just going to take our arrow here. We'll put it in the centre at the bottom, but if your bridge is designed such that you're carrying it at the top or whatever, you can do that too. Here we go, and I'll set 300 newtons. Alright, so the first thing that happens, once it's statically determinate, which means this little logo's up here, says you can. If that's red and off at an angle, it means it won't solve. But all of that's in the tutorial videos as well if you want to watch them and learn. Now I've worked out that if I've got a 300 newton force in the centre, then my reaction forces, the force that the table's got to exert on it, is 150 each side, which makes perfect sense to us because it's in the middle. But much more interesting is if I click on a member, it will tell me whether that member's in compression or tension and what force in that member there is. Okay? In this case, it looks a bit confusing, but that's in compression because one arrow is overlapping with the other arrow like this. And it's got 173 newtons compressing that member. And then this one has 173 in tension. This one, what do we got? Where is it? 173 in compression. This one, 173 in tension, so forth. This one has, what is that? 86 in tension. 86 in tension should be roughly as well. Okay, which is our critical member, or what's the maximum force in one of those members? 170, whatever that was? Yeah. So through this, obviously this is really simple bridge design and you've only got a couple of members and there's only two different forces. But if you've got a really complex design and some members are long and some members are short and it goes all over the place, what this gives you is which is my critical member or where is the largest force. And that's both on that member and the pins or the glue or whatever that's holding it. Right? And so that's really useful for two things. One is that I can change this design, and if I wanted to actually drag this point up, hang on, drag, alright, don't drag. Why won't that work? In the app it works. Go away, alright. Now theoretically you can, there you go, you can start moving these things. You should be able to make them longer. You can, if nothing else, you can click on that dimension make it 0.6 or something. You know, you can change, maybe, there we go, let's delete some things and start again. So if you use the app's actually probably more powerful than the website version of it. That's why, because they're all fixed. It wouldn't let me drag corners because they're fixed. There you go. So now if I did something like that, I can move it around however I want, make things bigger, drag this corner down here if I want, and you can distort the whole thing however you want. If you want to fix one of them to keep it there. Okay. And maybe we, just for a minute, let's fix this so it doesn't move. And we can drag this corner down here. And then we can fix it. You know, so you can change designs and play in the design process and try and optimize what your design looks like. Bloody bridge. There you go, that gives you a bit of an idea. So that's just a different design, but now it's doing the report again, and let's look at the forces. That's 130, that's 88, that's 150, that's 120, that's 112, it's 80, and that's 171. So if that was a slightly different configuration, I would have decreased all of them, but I've got one member now that's 171 rather than all of them. Okay, so like I said, the app's a lot better because you can actually use your finger and drag things around, and actually if you've got an iPad or something it works really well. This one might take a little bit more getting used to, but they're effectively the same thing. So you can optimize your design and you can remove members or add members. If you've got a member that's got a lot of force in it, maybe put a node in the center of it and give it a bit of extra structure or something like that. It'll decrease the amount of force. And you can take what is a starting point design and just optimize it a little bit using this, just decreasing the forces in those members, which is a really useful analysis tool, and I'd like you to do that on all three of your designs. Just try and optimize them a little bit to decrease the amount of force in each member. The second thing that we're going to use this for, and I'll talk about this in a second, is once you know the amount of force in one of those members, then you can do a test on the material that you're going to use and actually work out whether it's going to hold that or not. All right? And I'll talk about experimental design in a second. But what we actually want to do is make sure that we're using the minimum possible material. So if you've got 170 newtons in one of those members and you wanted to do an experiment on it and it's in tension, what might you do? Sorry? Well, no. So if you've got 170 newtons and I want to apply 170 newtons to something, how would I do that? Yeah. So if gravity's 10, 170 newtons is what in kilograms? 17. Yeah. And if it's in tension, basically I get my member and I can hang 17 kilos off it, and if it doesn't break, then it's going to do the job. Yeah? Simple as that. And so if it doesn't break, then I might try something thinner. Doesn't break, I might try a lighter material. Doesn't break, all right, now I'm starting to get closer to what my bridge is actually going to hold. Okay? And now that's not a definitive because it's a very simplistic tool, but it gives us a starting point for how big does the material need to be, what materials can we use, particularly what glue or bond at those joints, because you don't want to just hold that member, you will probably want to use one of the joints that you're actually planning to use at the top and hang the weight, because in most cases it might not be the actual member unless it's really light material that'll break. It'll probably be the way you fix it to something. So you can test both the member and the way you're gluing things together to really optimize that process. All right, so now it's not just taking a bridge design that we got online and building it out of paddle pop sticks and testing. Now it's actually starting to use that engineering analysis and optimizing the design to really achieve what you want, which is a very light bridge that carries the required weight. So this is a very good software because it's free and it's quick and it gives you those forces. There's online versions, as I said, and there's also those apps. So I want you to analyze each of your bridge designs using that software. And what I didn't show you Now it's gone away. Let's go back to that. It actually spit out a report for you as well, which is really good. Okay, so I'm just going to have to do a really simple little bridge. Let's just do a triangle. And we'll fix it at its bases. Oops, come on. 1, 2, and a force. All right, this is just for the example that over here on the right, I hit report. It'll generate a report, which is, you get a free body diagram of the whole thing, which is the reaction forces and the force that you applied. And then each element it'll break up. So it's got element AB here, and the forces and the equations associated with those, and then the free body diagram of that single element. So it's in compression, 531 newtons in this case. And then element BC, it shows you where it is, it shows you what the free body diagram, and it even gives you a shear force and bending moment diagram, which you guys won't know about, but you will as of probably statics and dynamics next semester. If not, then CS 2001 the following semester. So this gives you all of that for these members, which is fantastic. As far as what you guys need probably to grab a screen grab of that for your report, and the critical member I'm interested in. So probably a picture like that of the critical member, because then you're going to use that critical member for your experimentation. Okay? So this report is really useful. I do not want the whole report printed out and stuck to the back or something like that. I just want a couple of pictures out of it for each bridge design. Okay? So just use the most important parts of this, work out which member's the most critical, so which one's got the largest forces on it, and use that. Any questions on that? Yep, hit report, it'll spit it straight out there. And then I think you can email it to yourself. Cool, anything else? No, sweet, yeah, like I said, really powerful, free software, works very well. All right, so what I expect you to be doing over the next couple of days is finishing those analyses. It'll take very little time. You just set it up, you just draw your bridge, you do an analysis, maybe you optimize it a little bit, and I would like you to write up how you've optimized it in a couple of sentences, or what you found from it and how that then dictated the new design. But fundamentally get that together, because that's really easy, and then you can start designing an experiment. And that's what we're going to do. What we're going to do is design an experiment to actually test the materials that you're proposing. Now, I'm not going to set up this experiment for you, because each one of you will be coming up with different ideas of materials and different ideas of ways of sticking them to each other and all of this kind of stuff. So I'm not going to define this experiment. You guys are going to define this experiment. What do you want to learn from an experiment? Okay? And you need to think about that, and then on the tutorial next Tuesday, we'll actually go through the motions with that. So for the tutorial next Tuesday, I expect you to submit your bridge analysis using that Autodesk software. Okay? And I'll show you the brief. Basically, there's 3 sections in the next brief that you're filling out for the analysis. I just want that section that's got the bridge stuff. You submit that, submit a copy to me, and we'll quickly mark it. Not there, but that next couple of days we'll mark it, and assuming that you've just done what I've asked, then you'll get full marks. And also bring it along, because you'll be designing an experiment there. The other thing that I want you to do is actually read this resource, which I've got in these slides. Okay, and this resource is pretty good. It talks about how to design an experiment. All right? So a bit of an introduction, preparation, so forth. But the major important part is this idea of factors, levels, and responses. So they've just got a cooking example there where the factors are, you've got an oven and some ingredients. The levels are how hot is the oven, how much of each ingredient do you use, and then the response or the result is, hey, we've got a great cake, or hey, this tastes like garbage. All right, you get it wrong and it'll taste bad. So the test or the experiment that you carry out would be, all right, if the factors are set, then what levels of each do we do to get the right result? Now that's a very simple example, but for your stuff, what are the factors? Well, so I'm not talking about the bigger bridge, we're talking about just testing the bridge members now. So what might be one factor? Yeah, material. So you could either, maybe you've made the choice that you're using balsa wood, or maybe you're tossing up between balsa wood and paper and wire, or something a little bit stronger. So one of the factors is, what material are we going to use? What's another factor? How are you going to fix it? Yeah, that's another one. So how are you going to actually fix it? Maybe you got one method, maybe you got a couple, maybe you're going to use glue or a bolt, or, don't use bolts, they're heavy. What else? What about cross-section? So how thick or big is this material going to be to carry the load? What about shape? Because square cross-section and an I-beam cross-section are not equal in the way that they carry loads. Particularly I-beams are good for bending. They're much, much better. You use far less material to carry the same amount of bending. We got less bending in this situation. You guys haven't really learnt about bending yet. But there's different configurations that you can have there. All right, so those are the factors, and then what you're going to work out is the levels. So if you've chosen balsa wood, but one of your factors is what is the cross-section, maybe you try a small one, a medium one, and a large one and test the weight. Yeah, and so that's the levels that you're trying, and then once you get to the end, you work out whether the small one takes the weight or what. Ideally, what you want is to put 17 kilos in the example we had and break it, and then get a little bit bigger and break that, and get a little bit bigger and not break that, and that's your threshold. So if you have a cross-section this big over here that breaks and a cross-section this big over here that doesn't break, that's not telling you much. All right, you need enough data points to go from breaking to not breaking and have an idea of where in the middle you need to be. Okay, so we're going to design an experiment. I'll help you through it in the tutorial next week, but start thinking about it, read this section and do the analysis using that Autodesk. All right, and then there's a lot of other useful information about the process you go through to design the experiment and so forth. So read that and get familiar with it, and start to think about what you want to test and how you think you're going to test it, and then how that's going to feed back into your design. Okay? And then, once you've resolved what sort of material you want to use and roughly what size that material is going to be, go back to your design and think about particularly total weight. So now if you've just tested a bit of material and you've got 3 different designs, right, and one of those designs you needed a big thick bit of material, and one of those designs you needed a thin bit of material, now what you can start to do is calculate how much the design that has the big thick material is going to weigh total, and how much the design that has the very fine material is going to weigh. Because it's not just that the fine one will be the lightest, because if you've only got 2 members in the thick one and 10 members in the small one, then that's going to be different. So if you've got an idea of exactly how much material you need for each member, you can go ahead and calculate an approximate weight for each design, such that you're not just hoping for the best that you're producing me the lightest bridge, you're actually starting to understand that yes, that is the lightest bridge. How much material you need will also dictate roughly how much you expect this to cost. And if you know how much materials a Bunnings are and you know how much material you need, you can make a little calculation of that, and I want you to. Okay? And anything else you can think of, but fundamentally you're designing for function, so hopefully it's going to satisfy that. And then we're going to use a decision matrix. And in that decision matrix you're going to use cost, you're going to use weight, you're going to use its ability to carry load, and any other factors you can think about and how important you place those. But when you do the decision matrix, you'll do that from a place where you understand the structure, the first thing that we did, the detailed analysis. You'll understand the components from the experimentation, and you understand the cost and weight from a much better prediction than just where you're sitting at the moment with 3 designs and let's hope for the best. Okay? And you can do a decision matrix and decide which one you want to go with, and then that's the one that you build and we test. Does that make sense? Yeah? So this is the engineering process. It's a very simple context for this subject. It's probably still quite complicated by the time you do all of the things I've asked you to do. But when we're actually moving into later years, you'll be doing much more sophisticated analysis and making sure things are going to last for infinite life and not hurt people, and how much stress and how much can steel take and all of that kind of stuff. Much more sophisticated analysis, but it's in the same place. It's here in the workflow, and this is why you use it. You use it to understand a design and optimize it based on real facts rather than just feelings and hoping for the best. Okay? All right. So, the last thing that I'm going to do is we're going to go through the brief that I want you to put together, and then you guys can start to have a bit of a go at that Autodesk. Where's that? All right, this is online. This is the section that you're writing around this analysis, and this will constitute your analysis section in your report. Once again, same sort of format at the top. Purpose, so we want an introduction of sort of 4 to 5 sentences of why you're doing analysis, some sort of a summary of what I've just said, basically that we've got 3 designs and we need to understand which of those designs is the best based on structure and weight and performance and all of that kind of stuff. Then, first section, 1, is going to be structural analysis, and this is where you put your Autodesk force effects analysis stuff. All right? So you want to briefly summarize what you did for each of your 3 designs, and what have I said? A free body diagram drawn in the software. So that's that first diagram that you had there with the reaction forces and the force that you've applied and where you've applied it and so forth. All right, so just take a picture of that, a screen grab, and put that as your first figure in that section. The next thing you want is an indication of the critical member. So it could be that figure that has the critical member highlighted with the forces, and then you could have a free body diagram of the member by itself under it or something like that. So 2 or 3 figures in this section from that Autodesk software will be good, because then I can look at it, I can see how you've set up your bridge and whether you've applied weights in the right place. I can see where the critical member is and what those forces are, and then in the next section we're going to talk about the experimentation, and you're going to refer back to that. Okay? One other thing that you might learn from these 3 force effect analyses is that one bridge design might be 170 something newtons and one bridge design might be 20 something newtons. All right? And so you might actually work out that a particular bridge structure is far, far better for this application than another one. All right? And the other thing is you're spanning a long way, so if you've got a very shallow bridge as opposed to a large sort of archy bridge or something like that, there might be big differences about the way that the force gets redistributed through all those members, and you're going to learn that from this, so that's very useful. All right, the next section is experimentation, and you're going to write up the experiment that you do on the material. So you're going to design that experiment in the tutorial, and then you're going to write it up, and we write it up in a standard experiment. Has everyone done experimental briefs at school or before? Yeah, mostly. So you got aim, procedure, results, analysis, conclusion, and I've got a couple of dot points under each of those that I'd like this report to have. Now you can test one thing, or you can do a couple of tests if you really want to be, get involved in it, or if there's a couple of things you want to learn. But I'm happy for you to have one experiment here, so long as that tells you something. Okay? So one experiment on materials with different sizes or different types of materials for the same size or whatever is fine. The next section is our weight and cost calculation. That's what I was saying. So once you understand about roughly what cross-section or whatever you need, I would like you to approximate what weight you think your bridge is going to be. That's going to be really cool, because when we actually weigh your bridge, we'll work out whether you're close or whether you're completely a fair way away from that. But it's useful to have that estimation right from the very beginning, even as a relative thing between your 3 designs. And then the final thing is a decision matrix, and you can put a sentence at the beginning saying, here is the decision matrix that helps us choose decision matrix, and then we choose this design or something. Okay? So those are the 4 sections that go into this. For Tuesday, I want you to have completed 1. Okay? Bring that, print it out and hand it to us, and maybe have a copy for yourselves while you do the experimental design as well. We'll come up with a good experimental design for you guys to test what materials, what options. We'll lay out the lab report type thing that you need to do, and then you guys can go ahead and go and do that somewhere. Okay? So that's the plan for next Tuesday. Any questions on that? No? Cool. All right. Grab that software and start to think about, have a bit of a play with it, and ask me any questions that you might like, and we can find some tutorial videos too if you need. In the actual software, there's a button that says tutorials, and it has 3 or 4 videos there as well. So start to think about your bridge, spend a couple of minutes just playing with that while I'm here, and then if you've got any questions before you need to go, ask. Cool? So guys, when you actually do this, obviously it talks in straight beams, right? So if you've got an arch, you'll have to compose it in short bits of straight beam. So if I did an arch with short sections like that, now obviously if I have pins here, that's going to be basically a big loose wobbly chain, right? But if I did those weldments, that's fixed, and so that will actually behave as if it's a big curved solid structure, and it won't go anywhere, okay? The other thing, if you want to do something like a suspension bridge, I don't suggest that anyone does a suspension bridge because it's a bit dependent on fixing down here, but just as an example, you can do a horizontal member, have a weldment there and a weldment there to your verticals, so that's all solid, and then you can have pins to your sections like this, so that behaves like a cable because, or like a chain, because it's got pins, it can do whatever, and with more pins, you can hang the cables down like this. All right? Now, it's not going to be 100% perfect, but you can simulate the different response of the structure based on your choice of pins or weldments or some other combination thereof. If you want to make complicated shapes, you can use little sections to get that shape right. Question? Sorry? Oh. The other thing you can use in this software is construction geometry. Some of you might have been seeing that as you're drawing it, get wobbly and then you set up dimensions and things move. If you want to set up construction geometry and put dimensions on them, or you can set members up and put a dimension on it and then delete it before you actually do the analysis. So there's ways, obviously a triangle will always be set. Once you set 3 dimensions, that triangle won't move. So if you're trying to do rectangular stuff, maybe throw some triangles in there with some dimensions and that'll fix it in space so it doesn't get all, you know, crazy and silly geometry. And then you can just remove it or just use construction geometry. So you just have to think carefully about how am I going to get the geometry right using that type of technique, and then you'll have your bridge. So guys, when you're doing this on your phone, I think you can actually save it in the actual phone. If you're doing it online, you need to sign in to save your work, I think. So you might need to create a little account or something like that. I haven't experienced that, so if someone has done it, let me know. Obviously, it's helpful to save your work so you don't have to do it again. All right, guys, has everyone had a bit of a play with that, enough to be dangerous? Yeah, no one has any final questions for that before we call it a day? No? Cool. It's, like I said, it's a pretty simple little bit of software, but you can do a lot with it and you can learn things about your bridge designs that you might not have been able to otherwise. So have a play, do it while it's fresh, and get your 3 designs together, and then we'll talk about it next week. Cool. All right. Cheers, guys.